Hey everybody, Matt Morgan here. In this lesson, we're going to talk about your week 3 experiment, qualitative and quantitative analysis. We will define the terms qual and quant, talk about part 1 of the experiment where you identify an unknown substance, then part 2 where you find the empirical formula and work some sample calculations. Finally, we'll go over some additional resources you have to help you do the lab this week. So what do they mean by qual? So qual is an abbreviation for qualitative analysis. Qualitative analysis involves determining the identity of an unknown substance. Is something here? If so, what is it? In part 1, you will look for chemical changes. You will use this information to find the identity of an unknown substance. Basically, what you're doing is putting clues together and finding what the unknown is. Quant. They sound familiar, qual and quant, but they actually are very different. Quant means quantitative analysis. Rather than determine the identity of a substance, quantitative analysis tells you how much is present. So as you can expect, there's math involved with quantitative analysis. In part 2, you will find out how much water is present in a sample of hydrated copper sulfate. Now we'll talk about what we mean by hydrated copper sulfate in a little bit. Part 1. You will run a series of chemical tests. You will have known substances and one unknown. Compare the results of the known substances with the unknown. The ones that react the same give you a good idea of what your unknown is. This is an exercise in logic as much as in chemistry. Be careful of contamination. If you inadvertently mix some of your chemicals, your results will definitely be skewed. Use a specific pipette for each solution and don't mix the solutions until you are ready. Be sure to drop into the wells from above. Do not touch the tip of the pipette to your solution because some of that solution will go up into the pipette, it'll get mixed, and your results will not be good. On to part 2. So that hydrated copper sulfate, what are they talking about? So the formula has some copper 2 sulfate with water. What the goal of part 2 is to determine the ratio of moles of copper sulfate to moles of water. The substance is a solid. Even though it's hydrated copper sulfate, there are water molecules that are part of the crystal structure. An ionic compound with water in the structure is called a hydrated salt. So you're starting with hydrated copper sulfate. What you will do then is heat that and drive the water off. When you weigh before and after heating, that will tell you how much water is in the copper sulfate crystal structure. The difference in mass before and after heating is the amount of water that is present. What you will do is find X and Y. I also teach math. I love this meme. So we're going to find X with calculations rather than just circling it. But the math part involves converting the masses that you find into moles. After the water leaves, you should have a mass of what they call the anhydrous copper sulfate. And anhydrous means without water. You should also see a color change. The colors will be different between the copper sulfate with the water and the copper sulfate without. You'll have a mass of your anhydrous copper sulfate and the mass of water that has left. There's another video in the Lab 3 folder that talks about finding moles, but we will also do sample calculations in this video. So after you find the number of moles, divide both numbers by the smallest number. One of them will be 1 because you're dividing the smallest number by itself. The other number should be close to a whole number, and that is the number of moles of the other substance. I know that explanation doesn't make a lot of sense, but we're going to work an example. So I've got some data. It's completely fabricated. It's not in any way, shape, or form related to the numbers that you will have. I just made up these numbers so we can go through the calculations. Don't use them in your data sheet. So after running the simulated experiment, here is my simulated data. 0.053 grams of the anhydrous copper sulfate, 0.194 grams of water that was driven off. So we're going to find moles of the copper sulfate. The target unit is moles. I start with grams of copper sulfate. Then I apply the molar mass. The molar mass is, and the molar mass video talks about how to find it. I add up copper, sulfur for oxygens. Be sure to check my math. I get 159.6 grams of copper sulfate equals 1 mole. I apply it this way on my dimensional analysis grid because I want grams to cancel, and I want to be left with my target unit that is moles. Mathematically, I divide 0.573 divided by 159.6. Check my math on this. I get 0.00359 moles of copper sulfate. Going to do the same thing with the water. Target unit is moles. I have 0.194 grams of water. The molar mass of water, I come up with 18.2, but you should double check yourself. Just like the previous calculation, grams of water cancel. I'm left with my target unit of moles. Mathematically, I divide 0.194 divided by 18.02, and I get 0.01078 moles of water. Finding X and Y. We've got our moles of each. 0.00359 moles of copper sulfate, 0.01078 moles of water. Divide both values by the smallest number. So what I mean by that, the smallest number is 0.00359. Divide that number for the copper sulfate. The number divided by itself is 1. For the water, I get 3.0028, which is really close to 3. What those numbers tell us is that my formula is 1 mole of copper sulfate, and if there's a 1, we usually don't put a number 1 in front of it. We just have no number, and 3 H2O. So the name would be copper sulfate trihydrate. So some other resources for this week's lab lesson. There are lessons on molar mass that I referred to earlier. There are some questions on chemical naming, so I've got some videos on chemical naming. Now also, we have a Chem 1411 video channel. There's links to that in the lab class folder and the course information folder. That will allow you to watch any of the course videos at any time in case you need to look at some stuff that we haven't seen yet or review items that we've already seen. So these are video lessons for the entire course. As always, if you have questions, please contact me via email. We do have online office hours Tuesday and Thursday mornings from 9 to 10 a.m. Central Time. In the Blackboard course tools, there's something called Blackboard Collaborate. I was thinking about putting the whole link in here, but it's really long. So just find Blackboard Collaborate, go to the office hours session. I will be there. We can communicate over the voice over the web. I've got a whiteboard. We can work out problems. You can get your questions answered at that time. Also, you can make an appointment if those times don't work for you.